Hello everyone, welcome to Aryan Tutorials. Now we are going to discuss vapor pressure and cavitation, which are again the characteristic behavior of the fluid in mechanics of fluids and hydraulic machines. So first I want to give the definition for the vapor pressure. It is defined as the pressure applied by the vapor particle on the surface of the fluid. Okay, it is a simple definition. Easily we can say that the pressure applied by the vapor particles of a fluid, that pressure we consider vapor pressure. So how to understand this vapor pressure means I want to take a container. Inside that container I have taken a water, and I have given the seal to the container. The top is totally closed, the airtight container I have taken. So in to this I want to give the heat. It means I'm trying to increase the temperature. So when it reaches the 100 degrees centigrade, which is the boiling point of the water, automatically the vapor particles will be formed over the surface of the water. So whatever the vapor particles formed, these vapor particles tries to escape from the container, which moves upward. Okay, so in this condition here, airtight seal we have provided to the container. So whatever the particles are formed due to the reaching of the temperature equal to the boiling point, so they'll try to escape, and whenever they reach the top surface, so there is no way to escape. So in that condition again the vapor particles will try to move downward. Okay, now so whatever the vapor particles are forming inside the container by the increase in temperature, so the same vapor particles comes downward direction, and the pressure can be applied by those vapor particles on the surface. So this pressure applied by those vapor particles inside the container, so is called as here vapor pressure. Okay, so that is vapor pressure, and here the vapor pressure is less than the atmospheric pressure. That means we can consider it as a negative pressure, less than the atmospheric. Okay, so that is the understanding of the vapor pressure. That means wherever there is a possibility of creation of the vapor particles, okay, so in that condition we can face the pressure applied by those vapor particles in a liquid. Okay, that pressure is considered as vapor pressure. And I want to let you know in another way. So here I have taken same in an airtight container, the water I have taken. So to this I want to keep the temperature constant, but I want to reduce the pressure. Okay, if the pressure is reduced by any means, okay, that means I want to remove total air inside the container by any device. So when the pressure is reduced, what happens? The temperature also reduces. So according to the Charles law, here when we give the heat, so at the room temperature 20 degrees centigrade only, the boiling of the liquid, that is the water, starts inside the container due to the decrease in the pressure. Okay, so how can we say that? Means Charles law states that under constant volume conditions, pressure is directly proportional to the temperature. Okay, if you are reducing the pressure, means automatically the temperature also reduces. So at the room temperature only, the water tries to boil. Okay, and it will form the vapor particles. So again the same thing happens. The particles try to escape from the free surface from the container. So again due to the airtight we have provided seal, so again they'll move downward direction, and again they apply certain pressure. Okay, that pressure applied by those vapor particles is called as vapor pressure. Okay, so by the phenomena, by the consideration, by the facing of the vapor pressure in a flow field, in a pipe flow, okay, we can face the vapor pressure. So how can we say that? Means here the cavitation, here the cavitation is the effect which is produced by the vapor pressure inside the pipe. So assume here in a pipe, okay now, so in a pipe the water is flowing. So how the cavitation we can say that? Means the cavitation is an effect which causes erosion of the metal from its base metal in a pipe flow, in a pipe, when the pressure inside the pipe becomes less than or equal to vapor pressure. So during the flow of the fluid in a pipe, at any particular point, if the pressure is reduced less than the vapor pressure or equal to the vapor pressure, what happens? Automatically the boiling of the water starts. Okay, so in that condition it will form the vapor particles or vapor bubbles. Okay now, okay, so these vapor bubbles, whatever the vapor bubbles formed, they will flow along the pipe. Okay now, and again whenever these bubbles reaches the maximum pressure region, higher pressure region, at that place the collapsing of these vapor bubbles take place. Okay, so in that condition sudden collapse causes the sudden application of the forces on the pipe wall. Okay, these sudden forces causes the erosion of the metal from the pipe. So that is the effect of the cavitation which will be facing by the by the vapor pressure. Okay, so whenever the vapor pressure is created inside the, that means whenever the pressure is reduced equal to the vapor pressure or less than the vapor pressure in a pipe flow, so in that case vapor bubble forms, and these vapor bubbles flows along the pipe flow. Okay, whenever they reach the maximum pressure region, that is higher pressure region, in that place the collapsing of the bubble takes place. Okay, so that collapsing causes sudden force on the pipe wall, so that sudden force causes the erosion of the metal. So that is the phenomena which is the cavitation, which is the disadvantage for the pipe flow. Okay, that is about the cavitation phenomena which is due to the vapor pressure. Okay, that's it about the vapor pressure and cavitation. I hope you understand the concept of vapor pressure and cavitation. And if you have still any doubts, please feel free to give a comment to my video so that I'll try to clarify your doubts. And once again, thanks for watching my video. Thank you all. Please share my videos, and don't forget to subscribe to my channel, and please give suggestions to your friends to subscribe and to watch my videos. Thank you all.